Hey folks, welcome back to the MedTech Unboxed podcast. Today's guest is Ron Roth of Roth Technologies. Ron, thanks for joining the podcast.
Thank you very much, Steve. Glad to be here.
Great. Ron, we're going to talk about CathCAD, your proprietary software for developing microcatheters. And before we do that, I'll let you introduce yourself and CathCAD, and then we'll go through some simulations.
Good. I appreciate being here. CathCAD was originally released in 2012. We've had what I would call a very good run up in 2012. We had one customer, 2013 to 2014, 4 licensed companies. Somewhere around year 4 or 5, we hit what I would call critical mass. So if we fast forward to 2024, we're now well over 300 licensed users. We have over 80 licensed companies. And more importantly, we have what I would call all tier 1 medical device companies. And there is an annual licensing fee associated with the software. So one of our metrics that we use is basically, do customers renew every year or sign up for multi-year licenses? And we're always pleased that basically our retention rate is very, very high. So we think we made a contribution to the medical device industry, basically providing a tool that allows the catheter, microcatheter designer to basically design a device using analytical formulas to predict performance versus the prior method, in the 2000 timeframe, where people basically had tribal knowledge or would experiment multiple iterations to get to the best solution. So that's where CathCAD provides its value to the end user.
Excellent. Yeah. So what we're going to do is we're going to go through an example of a construct of a composite catheter, look at the parameters, tensile strength, torque, kink resistance, flexibility, and then we're going to change the parameters and look at that construct and see how the difference is. But before we do that, I noticed on the slide deck that you sent me, you've made some iterations over the years to the software. And it's pretty amazing to me if you look at this chart, and I'll let you explain it, but from 2017 to 2020 to the newer release in 2021, if you look at actual performance of those parameters that I just laid out to the simulation, it's pretty darn close.
It's amazingly close. So, we have some pride in these results. And this summary shown here basically shows version 2 and version 3. There was actually version 1, which goes back to 2012. And when we originally came out with CathCAD, if you look at some of the assumptions we're making, we're basically using composite laminate theory and lump parameter models, where a lot of the people in the design industry are doing finite element modeling and things like this. But the advantage here of CathCAD is you could set up a model literally in about a minute. And we're going to see that here in a little bit. But if you look at this, it's actual data for an 8 French guide catheter, which is very commonly designed in the industry. Our users go anywhere from 2 French OD all the way up to 25 French. And the software is basically, again, analytical formula. So, people say, hey, what's the constraints on the software in terms of size? Our answer is, the formulas just work. So if we look at our version 2, which is the 2017-20 timeframe, we're basically our errors on the 10 to 15%, which is, if you understand everything that's going on, our goal is to be in an error of less than 20-25%. So the fact that we're in the 10 to 15% range was amazing. And then if you look at basically 2021, which is our latest gen, we call that version 3.
Yeah.
Again, we took advantage of all the research being done in this research area. We look at the formulas and the assumptions being made. We then write code and evaluate with we have a base parameters that we make, how we evaluate things. We're all of a sudden now we're looking at errors of less than 5%, which is crazy.
Yeah.
Now, this is one design, but the fact of the matter is we have a number of users that report their results back to us on a periodic basis. And we're hearing consistently now from our users that if they do things properly, the errors that they're seeing between the model in real life are on the order of less than 10%.
Okay, that's amazing.
Yes.
When you sent me that slide deck, it's a really good slide deck, and that really caught my eye. So
Yes.
yeah,
Yeah. Very
excellent.
good.
Good job. So let's, at this point, Ron, let's run a simulation of a common composite catheter construct, and I'll let you describe the construct
Yeah.
using a PTFE inner liner with a tile layer. And then we'll change it because there's so much discussion these days about PTFE alternatives because of PFAS and other things, supply chain. So we'll change that liner and the tile layer to a lubricious compound. I'll let you describe that.
All right. Do you see my screen here? Basically, this is CathCAD Advanced. Is this on the screen?
Why don't you go one more time and do it?
Okay. Window entire screen. Here we go. I got it this time.
Okay. There we go.
Very good.
Perfect.
Thank you. So this is our CathCAD Advanced software. A license includes actually 3 software packages: CathCAD Standard, CathCAD Advanced, and we also actually have a multi-lumen software. They're all included. This shows basically about a 5 French OD guide catheter design. The ID is 0.56 inches. The inner liner is a PTFE extruded with a tile layer or P-backs. We have a braid layer of a 1 mil round, 16 wires, basically done on a Strieger braider, typical 80 pick counts, and then a outer layer of P-backs. So the wall total is about 5 mils. Again, entry takes about a minute or less than. And at that point in time, when you're done, you can hit the compute button, and there's our results in the lower left-hand corner. So basically, we have our flexural rigidity, longitudinal rigidity, torsional rigidity, burst strength. People look at kink radius, and then all your various tensile strength and torque capabilities. Okay. So very, very simple. And then, instead of having the user have to write everything down, there's this export to Excel button. So we click on that. And the first time takes a little while to do that because there's a lot of writing going on. After that, everything is pretty good.
Yep.
And once that's done, I think we're good to go. There you go. Modeling successfully. So this is actually hidden right now. But again, there's my Excel, and all the parameters that were computed are basically exported to the software automatically. So you don't have to do that. So then, Steve, you brought up this concept with the issue with PTFE potentially being minimized. So we're going to look at replacing this extruded PTFE layer with a lubricious P-backs material. We're going to pick P-backs 72 with 8% Everglide. Okay. Excellent. And we're also going to replace this tile layer with the same thing because it doesn't make any sense to do the same. So again, just like that, we've made 2 clicks and we've changed our design. And as you stated, Steve, we want to compare these 2 designs and see how they compare. So again, new design is in. I'm going to hit the compute button, and there you go. And we export that to Excel. And I've got my 2 models. Wow. Side by side. Jeez. And CathCAD automatically assigns a tracking number to the thing so we can keep track of things. Basically, we've got our designs up here, and now we can look numerically at the difference between the 2 designs. So you'll see basically we've got the new design being a little more flexible. Yep. On the order of 5% more flexible. Right? Here, that's about 8. So less than 10% change in pushability. Torque is basically the same. And again, here's where common sense comes in play. Why is that the factor? Most of your torque is coming from the braid layer. Yeah. And that matrix material that's filling the braid did not change. Basically, it's still P-backs 72D. So we would expect our torque to basically not change at all. And that's what we're seeing here. Right. And then we have our 2 different kink radius here and our tensile strength. So again, very, very simple to look at these designs and make a judgment. If you had these 2 catheters side by side, a human being would probably be hard pressed to tell the difference between them. Wow. that would be the conclusion. But
Yeah.
again, you know, you can go along that line and make adjustments really quickly.
Yeah. That's really cool. That is
Thank you,
really
man.
cool.
I appreciate it.
Yeah. If you could stop sharing.
All right.
Yeah. That's a really interesting tool, Ron. And I think people that are currently evaluating alternatives, it would be in their best interest to have a tool like this to check it out. I mean, basically, like you said, from a surgeon standpoint or somebody running a test,
Right.
even through a biosim lab, wouldn't seem like there'd be an impact on performance.
Yes. Typically, a human being can pick up a change on the order of 15, 20%. But when your changes are less than 10, very difficult. You know, somebody that's an expert may be able to find a difference. But, you know, again, less than 10% change is very difficult for a human being to determine.
Okay. Would we be able to run another simulation where we change the braid pattern?
Yes, sir.
May-
We talked about doing a pick count evaluation.
Yeah.
If we want to go
Yeah.
down that, you'll see
Sure.
how easy that is. So I'm going to share
Okay.
my screen again.
Go ahead.
So again, here we are looking at our design, and now we want to determine in this design, do I have the right braid density?
Mhm.
And the way of doing that is typically once a braid wire has been selected, is to actually look and maybe change the picks per inch.
Right.
So that's this parameter right here. In the early versions of CathCAD, you had to manually type in this value and hit the compute button and basically iterate along the way. One of the things that we've made it easy for the end user to do is basically this button called pick count macro. So I have a defined design, and I want to basically look at a wide variation of pick count for this design. I want to select this pick count macro, and it says, hey, I'm going to do this for you. Do you want to go ahead? And I'm going to say yes. And now I'm going to enter a min and max value and a step size. So we're going to go from 20. Oops. There we go. Up to 150.
Okay. Increasing the density as we go along the shaft.
50. Come on now. There we go. And then the question is step size. So we're going to go every 10.
Okay.
And now, so basically we go from 20 to 150, step size of 10, and I'm going to hit the start button. Software is going to make sure all the values are good. It says we're going to do 14 runs. And now here we go. And so now you can see how quickly this is being done. And you might want to say, well, where's all this data going? Well, number one, it's going into our Excel spreadsheet. But at the same time, we're going and making some graphical representations that the user of the software can look at.
Yep.
And there's 8 parameters. We're going to show basically 4. Number one is flexural rigidity. So you hear a lot of times the concept of that as pick count goes up, the device becomes more flexible. And the fact of the matter is that happens up to a certain point. So you can see for low pick counts, our flexural rigidity is a larger number. But then there's this minimum value pick count. And again, it depends upon the design, the braid wires, the braid angles, things like that, where you reach a minimum. And then after that, you'll see that the flexural rigidity will increase a little bit.
Okay.
Torsional rigidity, I'm going to comment about that real quick. Typically, your max torque occurs at a braid angle of 45 degrees. And for those of you who have had a mechanics of material class in college or something like that, you'll hear that the highest torsional strain, shear strain occurs at an angle of 45 degrees. That aligns with what CathCAD tells you. So we have certain indicators when we run models that leads us to the credence that, hey, we're doing the right thing, and that's one of those values. The other thing that you'll see interesting, again, is kink radius. So again, a lot of times you'll hear the concept that as pick count goes up, the kink radius gets smaller. And again, that's holding true here. And just for everybody's knowledge, we actually calculate 2 kink radius values. One is buckling, which is similar to Euler buckling, but this applies to a tube. And then there's also a failure mode where you'll fail a tube for a kink radius in a material failure aspect. So we actually calculate both value for the user to use.
Okay. Interesting.
Just very quickly, you want to see the Excel. So again, we had 2 models before, and now here's all our models, all stored for the user. So again, we've saved the user a lot of time not having to write things down.
Yeah. Wow.
Yeah.
And so just like you change the pick count, you could also, I mean, I saw there's a huge material database. You could change materials.
Exactly. So that's more on a manual basis. So again, here's our standard library that we provide to the user. And again, a lot of these values come from user data sheet, the manufacturer's data sheets. We're actually looking at generating our own because we believe in some cases that the materials provided by the manufacturer are not as precise as what we need in the medical device industry. So we've seen some cases where we think that the properties could be made better. And in some cases we've done that. But again, the model output depends on the material property data being proper. So that's one thing we're looking at here in the future to make things better.
Okay. It's an amazing database of all those materials, which are other common materials used in a composite catheter shaft.
Yeah.
You know, one of the things I was thinking about when we talked about braiding, you can stop sharing.
Yes. Okay.
You know, a lot of catheters that need higher delivery forces or deployment forces for structural heart, for instance, might use a laser cut hypotube in lieu of a braid pattern. Is there work being done to possibly simulate that as the backbone?
So we've looked at that. We've been approached by a number of companies to do that, integrate that into software. So step one, our first input on that will basically allow the user to enter the properties of that hypotube into the design, into CathCAD. So you might have the output parameters of that laser cut hypotube from either experimental testing or from like a FEM program. And so basically we could take those lump parameters and basically integrate into the software as step one. And then step two is basically, looking at research and seeing, hey, can we model a laser cut hypotube? What are the aspects? So basically it's the same properties that we're using now for, braids and materials. So there's the material itself, there's volume, it's the shape and things like that. So again, yes, we do have some work being done in that area, and hopefully we'll find some success and come up with a newer version of CathCAD. And again, something like that, when and if we do come up with that update, it's basically included in the software itself. So that's just part of our way. Any updates we make to the software are basically free to the user. You're basically gaining that capability as far as in terms of being just a licensed user.
Yeah. So you said materials, so you could be able to hopefully, whether it's a stainless steel hypotube or a nitinol or a cobalt chromium or whatever it might be. Yeah. Okay.
Yep, exactly. I mean, you see that in our braid repertoire. So we have stainless steel braids, we have tungsten, platinum, iridium, things like that already. Nitinol.
Yeah.
So it's built. It's just math. Sorry to make it seem like that simple, but it's just math.
Right. Okay. Wow. If you need any contacts at some of the laser processing companies that would work with you on this, I'd be glad to make some connections for you.
Very good. Thanks, Steve.
Yeah. Well, Ron, this has been real interesting. I'm excited to get this podcast on the market, get it out there for not the market, but to the market. Yeah, to the viewers. And maybe we can also share those results of that simulation that you did with comparing the PTFE to the Everglide.
Yes. So I can basically have it in a spreadsheet. I can save it and send it to your attention.
Okay. Awesome.
Right. And basically include it.
Okay. Before we head out, how can people get a hold of you and learn more about CathCAD?
Very good. Our website, and let's see if I have something here real quick.
Yeah.
There you go. Questions and answers. So Our website is cathcad.com, www.cathcad.com. And again, if you want to send us an email, simplest way to get a hold of our team is sales@cathcad.com.